So we're going to continue on our previous video and look at domain and range as well as operational functions. So just going to go back to that same page. So remember, domain is everything with your x values, so it's left to right. So the key thing is asking yourself, where does this graph start from the left? And then you can see it goes on forever to the left. Like if you could draw it longer, it would just go on forever. And where does it stop on the right? It goes on forever too. So it just goes on all the way. So it doesn't start or stop left or right. So how can I represent that? So that would be the domain. Well, if it's going all the way left, it's going towards what number? It's getting really, really big in the negative direction, which is negative infinity. And to the right, really, really big in the positive direction, which is positive infinity. In other words, the domain is all real numbers because it's everything. Now, you do an open parentheses because it doesn't include that number, because negative infinity is not a real number, it doesn't include it. Open parentheses on positive infinity as well. The range is the y value. So y is going to be up and down. So listening check, color in up/down. So up and down. So you start from the bottom, and where does the graph start? So I'm coming up from the bottom, the graph starts right there. I'm going to draw a line right there. That's where the graph starts. Then the next question is, where does it stop? It doesn't, right? It still goes on forever. It's just that we don't have enough people to draw it. So it starts at -3. And does it include that -3? Is there a line or a dot at that -3? Yes, it does. So you're going to do a closed bracket, and a closed bracket includes that number. And then it goes on forever. In which direction? In the positive. So positive infinity. And again, open bracket does not include infinity because it is not a number. All right, domain, again, left to right. So where does the graph start from the left-hand side? Where does it stop on the right-hand side? And then look at what it includes. So it starts at -3, but because it's an open circle, it doesn't include that number. So what did I say you do with that? An open parentheses. This is a listening check. Color in open, don't include. And where does it stop? It stops at 1, 2, 3, 4, 5, 6, 7, 8. And does it include that? Yes, because there's a dot, it's shaded in. So you're going to do a closed parentheses. So again, remember, open parentheses doesn't include the number, closed parentheses does. So that's the domain, that's the x, left to right. The range is up and down. So start from the bottom, come up. Where does the graph start? Draw a line right there. And then keep going. Where does it stop? Draw a line right there. So then that starts at -3. And is there a line or is it shaded in at that point? Yes, it is. So that's a closed parentheses because it includes that point. There's a graph there. And it stops at +2. And does it include that? Yes, it does, because it's a dot. So closed. All right, again, domain is x. The graph starts right there. And where does it stop? It doesn't, right? Because it goes on forever to the right. So my domain starts at 0. Does it include 0? Yes, because there's a graph at 0. So close parentheses. And it goes all the way to positive infinity because it's going to the right. And that's open parentheses because infinity is not. The range, so you come from the bottom. Where does the graph start? Right there. So draw a line. And then keep going up. Where does it stop? It doesn't stop because even though it's going up very, very slowly, it goes up forever. So it starts at 0. Does it include 0? Yes. And it goes on forever. So positive infinity. All right, what about this one? All right, so again, left to right. So it starts there. Where does it end? It doesn't, right? Because it keeps going that way forever. So that starts at -4. Does it include it? Yes, because it's shaded in at that point. So -4 close parentheses. This is a listening check. Put a box around the word domain to positive infinity and don't close infinity. The range. Okay, so before I actually do the range, I'm going to draw an isotope. An isotope means that it never really touches that line. So this is an isotope, meaning this graph is going to come very close to that line but not touch it. So that's where my graph starts from the bottom, but doesn't include it. And then it goes up forever. Even though it's going up really slow, it's still going up as you get up. So the isotope is at -4. Doesn't include it, so open bracket, because that line never really touches it. And then goes up forever to infinity, which is not a. So let's take a look at another way to rewrite it. So you can see rewriting like this, or you could write x between those two numbers. And then open bracket means don't put an equal sign. Close bracket means do. So y is the range, right? The two numbers. Closed brackets means equal sign. Closed bracket means equal sign. Domain again is X. So write X between the two numbers. Then open means no equal sign. Range is Y. Write the two numbers by Y, so -3 and infinity. And then close with equal sign, and then open, so no equal sign. Alright, domain is X, so X within the two numbers. Closed is equal sign, open no equal sign. Range is Y. Closed on 0, so equal sign and no equal sign there. Domain is X, so X and then -4 and infinity. Closed on -4, so equal sign there. Y. Open, so no equal signs. So different ways of working. Alright, so final thing we're going to look at is operations with functions. So if we had f of 3, 3, you can see if you match them up, 3 is really where x is, right? Which means wherever you see x in the problem, put the 3 in there. So it's going to be 3 squared plus 3, which is 3 squared is 9 plus 3 is 12. G of x and g of 3, so you're putting 3 in where you see x, so 3 plus 1 is equal to 4. F of -2, so you go to F and you see -2 is where x is, so you're going to put that where x is. Don't forget the parentheses around -2. So it's going to be -2 squared, which is 4 plus 3 is 7. Alright, now this one gets a little complicated. F and then g of 2 is what x is. So I need to find out what g of 2 is. So g of 2. So that means where the x is on g, that's 2. So I'm going to put 2 where I see x. So 2 plus 1, which is 3. Now, that is now my new x for f. So I'm supposed to find f of 3, which we've already found before, is 12. So let's do another one. This time I'm just going to write it all in. So g, and then the x part is f of 0. So I'm going to write the g function, where I see x, I'm going to put f of 0. So x plus 1 is f of 0 plus 1. Now I need to find f of 0. So I go f, and then 0 is where I see x. So it's going to be 0 squared, which is 0, plus 3. And then plus that 1, because all of that was f of 0. So that's going to be f of x plus 1, meaning this is all x. So wherever I see x, I'm putting x plus 1. So I see x squared, so it's going to be x plus 1 squared plus 3. And then go ahead and open the parentheses. X plus 1 squared is x plus 1 times x plus 1. Distribute. This is a listening check. Put a circle around the number 6, question 6. Don't forget the plus 3, and then let's simplify like terms. That's what you get. Let's take a look at one final example where I see x. I'm going to put x minus 2. So it's going to be x minus 2 plus 1. So basically whatever's in the parentheses is what you're putting wherever you see x. And that's pretty much it. Let's practice.